All right. On again, guys. We're not number 5 of this January 2024 CSEC month paper 2 exam solution. All right, number 5. So number 5 is a statistics question. It says the mass M in kilograms of 120 newborns means that this must add up to 120. Okay, I make a note right now, 120. In the hospital is recorded in the table below. So these are the mass in kilograms, and it's grouped data. So when we're estimating everything. First question wants us to state the modal class. So the modal class is the one with the highest frequency. Highest frequency is right here, 30. So this is a modal class. So we're just going to write that exactly as it appears there, which is 4.4 less than the mass, less than or equal to 5.3. And this is all in kilograms. So we must say kilograms. All right, so that is that one. That's a modal class. Let me put the 120 here instead. 120. So this add up to 120. Shift this over. All right, that's a mass. So it's greater than 4.4 kilograms, but less than or equal to 5.3 kilograms. All right. Next part says we have to complete the table below and calculate an estimate of the mean mass of 120 newborns. All right. So I know already that this is sum of my frequency, which is total number of newborns. That's sum of F right here. Sum of F is 120. Sum of F, which is the number of newborns, is 120. What we need is the sum of the sum column. So this is our sum column. F times X is what we call a sum column. It's a way of summing the mass of all 120 newborns. It's a quick way. But it's an estimated sum because here we have the midpoint mass, which is basically using the midpoint to represent the group. So what we're basically saying that the seven newborns in this group, each of them measured 3.05, which is not necessarily true, right? Maybe actually none of them measured 3.05, but this is the best way of estimating the mean, and hence the word estimate here. Statistics of group data is estimation statistics, simply because the data does not give you the actual mass of the newborns. You don't know the actual mass of the newborns. And if you observe these values, they are increasing by 0.9, because from here to here, the increase of 0.9, from here to here is an increase of 0.9. So that increase will continue. If you look at the lower limit values here, or the lower boundary values, I should say, they are increasing by 0.9. All right, that's pretty obvious. And also these are increasing by 0.9. So from 3.5 to 4.4 is an increase of 0.9. The values are all increasing by 0.9. So all we have to do is add 0.9 to this one and continue that trend. All right. Or if you want, you could take the average of these two values to get the midpoint value. All right. But I'm just going to do the simple way, 4.85 plus 0.9 times plus Mr. Shaw plus. That's 0.9. Calculator want to flap me this morning. Wants to flop me. It's 5.75. So this is 5.75. Now add 0.9 to this one, where that figure is 6.65. This would be 7.55. To complete this, we need to multiply these two values and multiply those two values. Let's do this one first. So it is the 5.75 times 29. That gives us 166.75. And I multiply these two now. That would be 7.55 times 8. That gives us 60.4. So the 60.4, for example, is saying that all the kids, all the babies in that group, all 8 of them total mass of all 8 of them is this. And so some of these values now represent the estimated sum of all the babies. Let's extend that down here. There's the sum of fx, which is sum of all the babies. I'm going to put the value right here. I'm going to add up all these values now. So I'm going to start at the 21.35. I'm going to add 71.1. Then I'm going to add 145.5. And I'm going to add 166.75. I'm going to add 186.2. Then we're going to add 60.4. There's supposed to be 1, 2, 3, 4, 5, 6 values added. Just make sure, just double check it. It's 1, 2, 3, 4, 5, 6 values. 1.35, 71.4, 145.5, 166.75, 186.2, 6.4. So the total here is 651. This is 651.3. That's the sum of fx. And so the mean, the estimated mean, which is written as x bar, which is the mean, it's an estimated mean, is the sum of your sum column by the sum of your frequency, which is the number of babies. So basically dividing these two values, this one and this one. All right, so it becomes 651.3 divided by 120. Let's shift this down a bit. Onto the line. The answer has to be in kilograms. Remember, the data is in kilograms, so your mean is also in kilograms. So it's going to be 651.3 divided by 120 babies. I'm going to put the exact value there now. They didn't tell us in the level of accuracy. I'm going to put the exact value there. I could give it to 1 decimal place. Well, the midpoints are 2 decimal places, are 3 figures. So let's give 3 figures. That would be 5.43. It's an estimate anyway. Kilograms, approximately. It's actually an estimate, so that's okay. That is that. Next part. It says, one newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3. This is that the mass is supposed to be greater than 5.3. So when I look where on the table the mass becomes greater than 5.3, and then we want all the babies in that group divided by the total of 120 to get the probability. Trying to write this better, guys. Kilograms. Okay, so where was the mass greater than 5.3? Let's look at the table. All right, so here's our 5.3. Here we are less than 5.3, right? Here we are still less than 5.3. So this is where our greater than 5.3 began, because this can be written the same as the mass is greater than 5.3. So that's where we started. And then everywhere up here, the mass is greater than 5.3. So let me indicate it here. So I'm going to put it in red. That everywhere up here, the mass was greater than 5.3 kilograms. If this over. And that total number of students represented by these are babies, I should say. All right, and that's the sum of those greater than 5.3 kilograms. So it's 29 in this group, 28 in this group, 8 in this group. All right, so we can show the calculation. It's a fraction. It's, well, I can put it because it's going to be the sum of those 29, 28, and 8. So this probability of the mass being greater than 5.3 kilograms is the 28, the 29, and the 9 divided by the total number of babies is 120. I don't need to show that figure. All right, I don't need to show that figure. Maybe I do because I want to give the answer a fraction. So, so let me see what it is first. So it's 28 plus 29 plus, it was 9 or 8. The last figure was 8, you know. It was actually 8. 29, 28, 28, 29, and 8. Or 29, 28, and 8. 29, 28, and 8. That's right in the right way. 29, 29, 28, and 8. What is that? 29 plus 28 plus 8. That becomes 65 over 120. And then that reduces to, in those terms, that would be 13 over 24 in those terms. 13 over 24 is your probability. All right, that is that. I'll put this in red. That in red. That is that. All right. Next part now gives us a cumulative frequency table. And our cumulative frequency table is a counting table. It's a way of counting your data, counting the number of babies as you go from group to group. And because we don't know the actual mass of the babies, what we know is how many babies measure less than the upper limit mass. All right, so that's what this is. So less than 3.5 kilograms, there were 7 babies. Less than 4.4 was the 7 in the first group plus the second group. Right? The 7 plus the 18. All of these are less than 4.4. So it includes those. All right. So it's a way of counting your babies as you go from group to group. Remember, the cumulative frequency column is a counting column. It's a counting column. But I want us to complete it, right? So we need to add up the frequency, continue adding the frequency. Let's copy the frequency values down. So these frequency values we need to copy down. So I can have them in front of me. So the frequency values are, so I have them over here. They are 7, 18, 30, 29, 28, and 8. So these are the frequency values. I have to copy that, paste it down here on my table. These are what I need to add. All right, so these would have been my frequency values. Just extending them down here. All right, so I'm adding those up. So my next value here would have been 55 plus 29. So these three would have already added to the 59, the 55 there. So this would be 55 plus 29. I can work that out. It's actually 84. Let's just make sure. So it's 55 plus 29. Yes, 84. And then it's the 84 plus this 28 more babies. 84 plus the 28 more this next group. So I'm gonna add another 28 to this. And that becomes 112. And then it's 112 plus the last 8. 112 plus this these are the every babies plus 8. And that becomes 120. So all 120 babies are less than that 8. All right, and since we need a frequent, more like one of the join a cumulative frequency curve, that's it. We need to know how many babies now are in the group before this, and would have to, these are going up by 0.9 as I've said, and so the value before this would have been less than, it will be the lower limit I've had in the table, right? This value. All right, that will be it. So I want to know how many babies would be less than the group before this would have been, let me put it in red, would have been where the mass is less than or equal to 2.6. I could have gotten it by subtracting another 0.9, and that would be 0 babies, because there are no babies less than or equal to 2.6. Because remember, the data started at a mass greater than 2.6. Right? The mass is greater than 2.6. That's where the data started. So there's no baby that's less than or equal to 2.6. So this should bring our cumulative frequency curve down to 0 at that point. All right. It's always important to do that. So the next part now wants us to use on the grid below, draw a cumulative frequency curve to show the information in the table. So they've actually started it for us with the first 3 points, and this point is not correct because they have it at 2.5. Should really be at 2.6. Let's look at the scale properly. So there are 10 lines here between 2.5 and 3.5. So it means that each line is 0.1. So it's 2.5, 2.6, 2.7, 2.8, 2.9, 3. 3, 3.1, 3.2, 3.3, 3.4, 3.5. So every line is 0.1. So this point right here really is in the wrong place. It should be here. Right? That's what I just showed. It should be 2.6. That's the lower limit. Right? Notice this point is on the 3.5. Less than or equal to 3.5. That's where the data started. 3.5. That's a frequency of 7. With the frequency of 7. So this should be where the next point is at 0. That point on the x-axis is wrong, guys. It's wrong. Everything is important. And this point is basically saying that there were no babies. These are less than or equal to the graph, by the way. See, it's showing how many babies are less than or equal to the mass. That's what this graph shows. So it's not just a it's not just a mass graph. It's a less than or equal to mass. It is showing less than or equal to the mass of baby. It shows how many babies measure less than or equal to any mass value that we see here. That's what it shows because that's the information we have. And this point here, they should ask what it means. It means that no baby, because the number of babies here is 0. No baby measured less than or equal to 2.6. So no baby, none of the babies, 0 babies measure less than, let's write that, 0. 0 babies. Number of babies that measure less than 2.6 is 0. 0 babies are newborns. 0 newborns. 0 newborns. Measured. Um, 0 baby measured less than or equal to 2.6. Less than or equal to 2.6 kilograms. All right, that's what it is showing. But let's put in the other points now. All right, remember that less than or equal to. Let's put them on in red. Yeah, let's put them on in red as I did with this point. So these two already, the next measurement, next values are these that we didn't have, right? These. So remember, it is the upper limit against cumulative frequency. Let's put on those points. The next point would be 6.284. The next point would be 7.1112, and then 8.0120. So these are the next 3 points that we need to put on the graph. Complete it. Let's copy these down. I'm just putting down the next page, so it's right in front of us, guys. So that's what usually I'm copying it down here. I'll erase it afterwards. All right, so the next point is 6.284. 6.284. So let's do the y-axis scale properly, by the way. So based on this, there are 5 lines between 0 and 10. So it's 10 divided by 5 means that each line is 2. Each line is 2 babies here. So this is 2, 4, 6, 8, 10. Each line is 2. right? And that's why the 3.5, this is a 7. But it should be 2 plus 7, 4, 2.5 was 7, 2.57. This is that point look wrong, you know. That should be 7. I was at the wrong place. And yeah, this point is wrong. So show you where it is supposed to be. Tell these people. 7, 2, 4, 6, 8. Right? So this is 6 and this is 8. This point really should be here. Okay? 2, 4, 6. Here is where that point should be. And if you see that in the exam room, don't be afraid to correct it. That's where 7 is. Let's check the other one, which is the 3.9. No, the 4.4, right? 4.4. 4.4 with the frequency is 25. Let's see if that one is correct. 25. Let's see this. 25. Yeah, 25 is correct. Okay. That's 20, 22, 24, 26, 25 is right here. That point is correct. The first 2 points that they gave us down here, this one and this one, they are incorrect. All right, but this one is okay. All right, so let's continue though. So I'm gonna mark this one as a good point. That one. All right, let's continue. It's taking longer than we should. All right, so 6.2 is 84. 6.2, 84. That's the next point. 6.2. So we're 6.2. 6.2. So this will be 5.5. This will be 6. 6.2 is right here. 6.2, 3, 4, 5. Right. So this is 6.2. Let's mark it. This is 6.2. Has a frequency of 84. So we're going to put 84. So this is 80. This is the 80 line. So this should be 82, 84. So 84 is on this line. So that better. We're coming up on the 6.2 line, which is this one to meet it. So make sure we get it the right way. And that is the point that we want. Well, this is 84, right? So we're talking about right here. The one next point. Okay. That's the one next point. Then we want 7.1, 112. 7.1. It as if we're missing out a point. It's like a wide gap. Maybe not. I didn't put in 5.355. That's not there. 5.355 is not given. Let's see. Nope. 5.355 was not given. So this is 5. This is 5, 1, 2, 3. This is 5.355. 5.3 right here. And that one, the frequency of 55. So coming up on this line, it's 5.3 to meet 55. Let's make sure it was 55. Yes, it's 55. So that point was not shown. 5.3, 55. This is 50. And that is 60. 55 is right in the middle here. 50, 52, 54. That is 55. So coming right in the middle there on this line. So this is the point we're talking about right here, or on this line. So that is that. That's the next point. I didn't give that one. All right, fill that one in. Those are the points so far. The next one is this one, right? 7.1112. We didn't put that one in as it. So this will be 7, and this will be 7.1. Let's mark it. 7.1, 2, 3, 4, 5. Yes. Just double checking. This is 7.1. We're coming up on this line next. All right, coming up on this line. We're going up to 112. Up to 112. So follow this line to reach 112. So this is 110. This must be 112. I'm going to meet that one there, right here. Talking about that point. So we're now at this point right here. All right. And then at last point is 8.0, 120. That one is easy because 120 is right up on the top line. And the 8.0 is right here. 7.5, 8.5, this is 8.0. I'm coming right to meet right up on the 120 at the top. Right up there. So it's this point right at the top. So those are our points. Draw a smooth curve through those points. Let's draw it in blue. Let's draw a smooth curve through those points in blue. So remember, don't use any ruler on it, guys. It's a curve. Let's draw the best curve you can through the points. This part look kind of straightish, but we don't have any control over that. I'm taking it to the correct points. This point is wrong, and this point is wrong. All right, put them to the correct points. And that is it. Cumulative frequency curve that O gives shape. All right, remember another name for the cumulative frequency curve is the O-give. O-G-I-V-E as that shape. All right, characteristic shapes. Let me take these out now. I don't need these. I just brought them down here to see where the additional points were. All right, so it's going to start taking a little bit longish, but that's what it is for that device. All right, so next part, I've drawn a graph. What does it want us to do? Anything else? Let's make sure. Nope, that's just one last question. Use your diagram to estimate the median. Remember, the median is the mass of the newborn. That is the middle of the distribution. And since there are 120 students, newborns, the position of the newborn is the 60th halfway. So the position of the median newborn baby is the 60th one. So this is the 60th baby in the median position. So this is only the position of Q2. Remember, Q2 is the symbol for the median. It is the second quartile. So come across on the graph. Looks like a nice valley there. Looks like it is right at this line here. Just gonna use this value. All right, well, that looks close enough. It's an estimate anyway. I want to say it's 5.5. No, not everybody's gonna get 5.5, guys, because it all depends on how you draw your graph. Some persons might have drawn this part a little bit lower down, or might have drawn it a little bit more above. So it can vary a little bit. So you don't have to get this exact value that I've gotten. Anything there. So I'm going to put that as my Q2. This as my Q2. The circle in blue. And that is my Q2, my median. And then write it. The median, which is Q2, second quartile is 5.5 kilograms. And that is it. Nice question. All right. And that ends number 5. We're going to do number 6 in the next video. All right. So let's pause this one so we can start the next video. Okay.